Hello, everyone, and welcome to our BlackTIDES training event. We are Black in technology, informatics, data science, epidemiology, and social science. Our 2023-24 Executive Committee consists of Kimberly Dees, who is our informatics and LinkedIn lead, Sia Seiko, who is our strategic operations, Twitter lead, and communications lead, Andrea Hobby, who is our epidemiology lead, Lauren Shores, who is our mentoring and networking lead, Hannah Hanfi, who is our statistics lead, and Natasha Wooten, who is our graphic designs lead. Today's presentation, titled Introduction to Health Informatics and Health Data Science in R, will be presented by Andrea Hobby, who is a data scientist and is the BlackTIDES epidemiology lead.
Healthcare facts generally stored as characters, words, symbols, measurements, or statistics. Healthcare data by itself is not useful for decision making, but healthcare, along with other information like event information, becomes more useful. So we'll see on the next slide the difference between data and information. So here's an example of data versus information. For this figure, we have you can have a single data point like blood pressure, 120/80, but by itself, it doesn't mean anything as a single data point. But if you add in some more information, like let's say it's John's blood pressure on a certain day, then at that point, it becomes more useful. And with the additional facts attached to it, we can use information to help create knowledge. So a way to think about knowledge is that information is applied to rules, experiences, and relationships with a result. It can be used for decision making. For data science, data analytics apply to health information and research studies based on healthcare information. This is an example of transforming healthcare information into new knowledge. So we'll go over what is health informatics. And health informatics to me is the science of how healthcare data, health information, and knowledge to improve human health and the delivery of healthcare services. To me, healthcare informatics is concerned with the security, privacy, and data standards, interoperability, system architecture, and legal compliance of electronic health records or electronic lab reporting and information systems. So here's an example of all the different things you can do with healthcare informatics. You have you can do computer science and health informatics. You can focus on clinical decision support, interoperability and integration, which is for some of the jobs I've had as a healthcare data scientist. That's been really important for me to enable me to do my work. We have public health informatics. There's just so many different things you can do within the field of health informatics. And we'll go to the next slide. So what is health data science? We're going to focus on that for a little bit. Health data science. To me, statistics, health informatics, computer science, and healthcare subject matter expertise all rolled into one. For me, I'm a health data scientist, so in my job, I regularly use statistics. Health informatics is really important. It's like the foundation of what I'm doing. Computer science, I don't do a lot of computer science, but it's really important just to understand the basics of computer science. And healthcare subject matter expertise for me, that's epidemiology and a little bit of like health services research. But there's so many different ways you can be a healthcare data scientist. But it's a very interdisciplinary field that is always evolving, and there's always something new to learn. So here's like the health data science life cycle, or it's the data science life cycle, but for healthcare, it would be, business problem understanding. So let's say you're working at a clinic or a hospital, or say a large public health department, you really need to understand how it functions and operates in order to be be a data scientist, or if you say you're working like in a radiology department as a data scientist, you really need to understand how the department operates and functions, how they make decisions, who the key stakeholders are and what they really need, who the end users are of your model. It's just really important to have a thorough understanding of everything before you start even getting to the data collection process and further along in a data science life cycle. Also, data collection is really important, especially when you're thinking about getting quality data, because if you don't have quality data, then it's really hard to develop a robust machine learning model as a data scientist. Also, you want to make sure your data, when you're collecting your data, it's not biased, or you want to minimize bias as well. So this is something you should think about as you're collecting your data, and then you have to clean your data and prepare it. You can do this in R, you can do this in Python, or SAS. I've used them all as a healthcare data scientist. And you do explanatory data analysis. And then after that, you could do some feature engineering. So feature engineering is basically you're going to transform your variables that you're going to use for your model and create new features from existing data. So you might change like, what's a good example? You just might learn the process of talking to your business stakeholders or whoever at the healthcare clinic or hospital you're working at, that they have some ideas of like what they're looking for, and you might be able to incorporate that into a feature for your model. And then also you have machine learning after you get through your feature engineering. At this point, you're going to be selecting an algorithm, which encompasses the development application of your machine learning process. And meet this person real quick. And after that, and there's also so many different machine learning algorithms in data science, and that's like a whole another lecture. And after you get through your machine learning, you're going to do evaluation and validation, and you only want to make sure your model is accurate, as accurate as possible, especially in the healthcare setting. If you're using, let's say, a machine learning model to predict whether or not someone will get cancer or something like that, you really want that to be as accurate as possible. So that's really important. And then you also have data visualization. So you can visualize your findings and communicate through visual representations such as charts, graphs, and dashboards. And R, you can do dashboards in R Shiny, which I think will be a fun talk to do later, maybe early next year for Black and Data Week. And then some other things I think that are important to the data science life cycle, or kind of touched on this before, data ethics and privacy. You really want to ensure the privacy of your data and your security concerns. Just use the data responsibly. And I kind of mentioned this before, you really need a domain expertise, because I've worked on projects where I was the only person with healthcare expertise, and people were trying to do things with data that they shouldn't do with healthcare data. So so it's really important just to have domain expertise. And if you don't have domain expertise, you work closely with someone that does have it, so you can develop good data science projects. And then it's really important to have good communication skills. And then it's also something that I think should also be added to this is deployment integration. Because at some point, if your client really enjoys your machine learning or data science project, you're going to have to deploy it into production. And people are going to interact with it in the real world. So you really want to integrate your whatever model you built into existing systems and deploy it. For some jobs, like in my current job, like I do the deployment, but at some jobs you might have like a machine learning engineer doing the deployment and integration. So it really depends on where you're at. And also, I think another thing important to point out is just continuing to monitor whatever you build, just because models can change over time, especially using real-time data. There can be shifts in the data which would degrade the performance of your machine learning model. So you really want to be able to just find a way to continuously monitor your models to see how they're performing. And then also you must want to stay up to date to different techniques and technologies, and just kind of just continue monitoring the process when you're doing it for whatever area of healthcare you're working in. Some areas of health data science are natural language processing, which you could be constructing patient diagnosis information from clinical notes in an EHR. You could use computer vision and to analyze radiology images using image recognition algorithms. You use machine learning, which is what I do for work, and build models of predictive utilization of healthcare resources for a hospital. There's reinforcement learning, where you can develop personalized treatments. Also, there's like causal inference, and this can be used to determine the effectiveness of treatment by comparing outcomes to in a treated group against the control group. And but there's just lots of different ways you can do machine learning. Even these areas, there's just so many different projects and things that you can do. And let's see next. So what are some similarities between health data science and health informatics? So health data science and health informatics rely heavily on data, both rely heavily on data to drive decision making and improve healthcare outcomes. And they involve collecting, storing, and processing, and analyzing data for insights. They both are multidisciplinary, draw on computer science, stats, medicine, biology, and public health. Health informatics involves managing and utilizing electronic health records, while health data science may want to work with EHR data to perform an analysis. Both are really important. Both fields use research analysis to gain insights for healthcare trends, patient outcomes, and clinical practices. Healthcare data scientists may use data analysis techniques in this process. Health informatics and health data science intersects with health information technology. Health IT solutions are crucial for healthcare operations. Both fields use healthcare decision support systems or clinic decision support systems, which helps clinicians to make informed decisions. But it doesn't have to be just clinicians. I've built models for like state health departments to help them make informed decisions about how to deploy public health resources. So there's different ways you can do that. And they both share a common goal of improving the quality and safety of healthcare services through data-driven approaches. And then you have health data science and health informatics can be applied in public health initiatives, which I mentioned before, like disease surveillance, which was what I used. That's when I first actually learned about health informatics, when I started working in disease surveillance. And I just realized how important it was to be doing good health data science work, and epidemiology and public health, population health management. Both must adhere to healthcare data privacy regulations and standards. So it's really important. Some people outside of healthcare don't know about that. So if you're working with a team that doesn't have any healthcare expertise, but you are the healthcare expert, you want to make sure you let everybody know, because you don't want to get in trouble because people, they don't know. So here's some of the differences between the two fields. Health informatics, which makes sense, it has a broader scope than health data science. It includes the management, organization, and utilization of health information. And also it involves the design and implementation of information systems to support healthcare delivery, decision-making, and overall healthcare management. Whereas health data science focuses on health-related data to extract insights, identify patterns, and make predictions. As I was mentioning before, but you can't really be a good health data scientist. Well, you can be a good health data scientist, but the foundation of everything is health informatics. If you don't have like a robust, let's say, health information systems infrastructure where you're pulling in all the data from, let's say, like around like the country, let's say the CDC, they have to have databases where they pull in data from around the country, and it has to be cleaned and standardized so a healthcare data scientist can draw insights from it. So it's really important that you kind of understand that both of these in order to be a healthcare data scientist, and I think vice versa too. And then methods, both utilize, or health data science utilizes data analytics and statistical modeling and machine learning algorithms to analyze large insights. The emphasis is on extracting meaningful insights and patterns to inform healthcare operations. And then for health informatics, it's more concerned with the design and implementation of health information systems, electronic health records, health information exchanges. It focuses more on the effective use of technology to manage and communicate health information across healthcare settings. Role, a healthcare data scientist is typically responsible for analyzing the data sets, which probably get by now, and also developing predictive models and providing data-driven insights to support healthcare operations or improving patient outcomes. For a health informatician, they're more focused on the design, implementation, and maintenance of health information systems, and ensuring the interoperability of healthcare technology and managing health information securely. All right, so we're just going to do a quick overview of R. So R is an open source programming language, and RStudio is an integrated development environment for R. They are used for data analysis, statistics, and data science. Why use R? It's open source. It has a big online community. So if you have questions or you're confused about something, there's always someone that you can ask for help. R has lots of libraries for almost every statistical analysis. Also, it's free, so why wouldn't use it? And also, you could check out, I think RStudio community is like a good resource to learn more about how to use R, or maybe you want to develop a dashboard in R Shiny. That's a good community to look at. And also, if anyone still on Twitter or X or whatever it's called, RStats is a helpful community. And here's this overview of some of the data types in R. We have numeric, we have integer, we have character, which is like a string. We have dates. We also have date times, but I didn't include that. And logical, which is basically a Boolean. And here's some data structures in R. We have vectors. Vector is a one-dimensional array that can hold element of the same data type. So as you can see here, I have a numeric vector. And you get a list. It's a data structure that contains elements of a different data type. Elements can be vectors, matrices, data frames, or other lists. So we see the list I have here. You can also have a data frame. Data frame is a two-dimensional tabular structure similar to a matrix, but it can also store columns of different data types. And we have an array here, which is a multi-dimensional extension of a matrix. It can have more than 2 dimensions. And then we have matrices, which I have here, which is an array with rows and columns, and all elements of a matrix must be of the same data type. And I thought I'd include a list of some common R libraries that are used in health data science. Maybe health I can't even say it right. Informaticians use it as well, but I've used some of these libraries from health data science, especially tidy, ggplot. I've used Carrot, and here's some of the Lubridate, RPart, Shiny, which I kind of mentioned before. Here's fairness in R, which is the one I learned about recently to help mitigate algorithmic bias in machine learning models, but using R. I know some healthcare data scientists are using it for that reason. So I just thought I'd give you a list of R packages that you could use. And let's go to, let's check out a dashboard. It's not a dashboard I created because that takes more time. So we're going to go see one that CDC did. So hold on a second while I pull up a dashboard. All right, so hopefully everyone can see this dashboard. So I thought this was just a good example to see what you can do using health informatics. So basically, like you wouldn't be able to create a dashboard like this if you didn't have a good health informatics or health information system. So for most dashboards like this, there's a large database somewhere for this one, since the CDC and probably in Atlanta, that basically is getting data from basically every single state. And so how that information basically that data is standardized and transmitted to the central database. And then once it gets to that central database, you have the analysts or data scientists or epidemiologists or whoever will create data visualizations like this, just to show trends and outpatient illness or viral surveillance. I just wanted to show this just because you wouldn't be, if you didn't have the infrastructure of health using health information systems, you wouldn't be able to have like when like in 2020 all those COVID dashboards, you wouldn't be able to do um these sorts of data visualizations and gain insights. And let's see what's next. Hopefully, let's see. Okay, I think now we can do some questions. So let's do some questions now. So let me see if I can find the chat. And what questions do people have?
We'd like to thank everyone for attending today, and we invite you to visit us on our socials. We are on LinkedIn, GitHub, YouTube, and Twitter. You can also email us at contact@blacktidesdata.com. Once again, we thank you for your support. Yours in data, Black Tides.